Good morning, this is Mr. Walker, and today we are going to be talking about the exponent rules. So, this video will be split up to talk about the specific rules that we need to talk about for each day. For the first thing, rules that we're going to talk about are the ones from the product rule down to... Actually, I think we're just going to be doing the first two right now. So we're only going to be doing... Oops, sorry. We're going to be doing two right now. We're going to be doing the product rule and the quotient rule. So before we get into these, let's take a look at what we got from this chart. So I'm going to go to the chart. I'm going to snap over the rules so we can understand what it's exactly talking about. Because it's not giving us a whole lot of definitions, but it's giving us essentially what's going to happen. Okay, so let me open up the snipping tool. Let's take a look. Alright, so here's our product rule. Let's bring this over to the definitions just so we can understand it a bit better. So let's paste this. Alright, so the product rule in its most basic terms and understanding it says if you're multiplying two numbers with the same base but different exponents, you add the exponents and put it on the base. So, just for us understanding, whenever we have a exponent involved in our number, we have two things. We have a number, so here's our number 1, and it's being raised to the second power. Now, these two right here have two different names. This right here, this is our power. It's also known as the exponent, and in some cases it's called the index. But for right now, we're going to be dealing with power as the name of it, or the exponent. Now this is called the base. So the larger number, that's always called the base. This is called the power, or the exponent, or the index. Has a bunch of names. So what this product rule says, if we're multiplying two numbers with the same base but different exponents, we add the exponents together. So let's look at a couple examples. So let's look at if we have 2 to the third power, and we're multiplying that times 2 to the second power, what we would do is we would rewrite 2, but up here for the power, we would be adding 3 plus 2, which would end up being 2 to the fifth power. Now you could necessarily take both of these two things and take them to their respective powers, but in these problems that we're going to be doing this week, we're going to be mostly wanting to see what they'd be written in exponent form. So this is the exponent version of this. Now, this also works the same way with our x's. Now, if you remember when we were dealing with multiplying different monomials and binomials, whenever we dealt with an x to a certain power times another x, we would usually add the exponents there. So let's say we had x over here, and we're multiplying that times another x. What we're doing here is we're really adding the exponents for these two. Now, even though there's no exponents specifically written there, there are exponents right here and right here. It's an implied exponent. It's actually a 1. So we have a 1 here and a 1 here, which means over here for our x, we have 1 plus 1. And that equals our x to the second power. That's all we always write it as, x to the second power. Now this can change no matter what type of numbers we're dealing with up here. We're still essentially adding these together. So let's look at another one. Let's say if we had, I don't know, let's look at a fraction, for example. Now, you're not going to necessarily see it, but this is just for the edification of seeing it. So let's say we have y over here, and we're multiplying this times another y. Now let's get two fractions. Let's say we got 1/2 and, I don't know, 2/3. Let's say those are exponents. What that means is we would, actually, let's make that exponent a little easier to do that. 2/2, yeah, let's do that. So if we're multiplying these two, even though these are fractions, we essentially do the same thing. We have y, now it's to the 1/2 plus 2/2. Since these both have the same denominator, we just deal with this like how we do with normal adding of fractions. We add them together. This gives us y to the 3/2. So, pretty simple. Now, that's our product rule. The next rule we're going to deal with is called the quotient rule. So let's take a look over there. To the left. All right. And that's good. All right, quotient rule. Actually, let me take a picture of this rule right here just so you understand it. Now, I know I told you guys to copy this, so please make sure you have this copied in your book. It's better for you to have this reference already than going back and forth between different videos and different images and such. So let's put that back here. Let's slide back over. All right, so our quotient rule is similar to the product rule, except we are dealing with division this time. So let's say we have two numbers, they're both the same, two bases with different exponents. What happens is we subtract the exponents and we put it on the base. So if we're dividing two numbers with the same base but different exponents, we subtract the exponents. So there's two ways that they could write it. They could write it like how they do right here with the division symbol, or they could write it with a fraction in mind. So let's take a look. I'm going to show you the same problem but in two different ways. So let's say we have a to the second divided by a, I'll write it this time to the first. What ends up happening here is we would take a and we would take it to the 2 minus 1 power. 2 minus 1 we know is 1, so this would be a to the first. Now, conversely, what they could write this as, instead, they could write this same problem as a to the second over a to the first. All this means is we're still subtracting. So we're always going to take the exponent from the first one and subtract it from the exponent on the second one. So we got a again to the 2 minus 1 power. And that gives you, again, a to the first. This is the same thing if we had to deal with numbers. So let's say 2 to the second power, not to the second, let's go higher. Let's say 2 to the 7th power. And we're dividing that by 2 to the 3rd power. This would give us 2 to the 4th power. Because 7 minus 3 is 4. Now, there are going to be some cases where we're going to have to do some manipulation with some of the problems. So if we see that in our Khan Academies for this week, I'll address that when we get in our Zoom meetings. So this is our two basic definitions for the first two rules. Your assignments today are based off of these two, okay? So they're based off of the product rule or based off of the quotient rule. So next video that you'll see will be dealing with some problems off of Khan Academy, okay?